So with that, we'll be coming up to our next speaker before the break. So Andrei Serban is a CEO and co-founder of Fuzzbuzz, a San Francisco-based cybersecurity startup. He has a quite interesting background. He dropped out of university to accept the super famous Thiel Fellowship and start Fuzzbuzz. And his company went through Y Combinator in winter 2019. And he has raised $2.7 million seed round. And he's going to talk about how developers can make sure their code is secure. Welcome, Andrei.
Thanks for having me. And it's a pleasure to be here. Super awesome event that the organizers have put together. So really excited to get a chance to talk more about how developers can make sure that they're writing secure code and staying secure in today's, I guess, fast-moving development workflows. So once the slides are up, I'm happy to get started. Cool. All right. So we can start with a great cliche slide about how security is hard. So in 2019 alone, there were reported 1,400 data breaches. That's 1,400 different companies leaking users' data in some way, which is about like 4 data breaches per day. So that's a ton. And these aren't really sketchy companies that you haven't heard of. A lot of them are actually kind of companies that are respectable. They have great tech teams and security teams. Companies like Facebook, Marriott, Capital One, Equifax. I'm sure you've heard about that one. So, it's statistically very likely that you've actually worked at a company that's been hit by a data breach at this point. So we kind of just take data breaches as an inevitable cost of doing business nowadays. And so the reality is that these data breaches are often not the result of crazy hackers like you see in the movies, but they're more a result of incorrectly configured tooling, simple exploits in your code, through SQL injection or cross-site scripting, or just a known vulnerability that, in some third-party library that you're pulling in. And I'll talk about all of these in a bit more in a bit more detail in a bit. But today we're just going to talk about how you as a developer can automate the detection and management of these security tools with as minimal work as possible. Now, before we get started, I just wanted to point out that I am assuming that you are a developer. I am assuming that you probably work at a startup with probably no real security team. You're maybe the most senior developer on your team now, and now it's your job to make sure that your code is secure, and you're not quite sure what needs to be done. So that's exactly what I'm hoping to cover today. So I also want to point out that I will be listing certain tools later on. I have no invested stake in any of them. These are just tools that I've found to work well for for our company and for other companies that I've worked at in the past. So each team is different. Try these out, try other tools. Don't take any of this as gospel. And so lastly, I will be focusing more on the application security side of the DevSecOps toolchain, because that's what I'm more familiar with. So I won't talk too much about detection, response, monitoring, and production, and so on. All right, so before we get started, a little bit about me. My name is Andrei. I'm the CEO and founder at Fuzzbuzz. So we're a fuzzing tool and infrastructure company. And if you haven't heard about fuzzing, I mean, that's fine. Most people haven't. It's a type of automated testing methodology that's exceptionally good at finding bugs and vulnerabilities in your code that developers and other tools tend to miss. And so I don't want to spend too much time talking fuzzing today, but we are doing a workshop right after this talk called Automated Bug Finding with Fuzzing. I strongly recommend you check that out if you're interested in learning more. And before Fuzzbuzz, I worked as a backend developer at Confluent, Cloudflare, and RBC. So I'm a developer who ended up doing security work. So I approach all the security work that I do through a developer first mentality. I also threw my email up there. So if you want to talk about fuzzing or DevSecOps or starting a company, raising venture capital, dropping out, definitely reach out. I'm happy to answer any questions. All right, so before we talk about DevSecOps, we got to talk about DevOps. I assume most of you are familiar with the term already, but for context, we should just go through some quick history. So it came out largely 10 years ago when there was this huge culture shift to Agile, because once upon a time, the way to do, to do software was basically this really long, take this really long timeline, be like a couple months for each process, and then at the end, you have this finalized kind of piece of code that you would just push out, and that would be that version for the next, I don't know, couple months, sometimes even up to a year. People started to realize that this way of doing development wasn't very effective at basically delivering for users, because if a user wanted a new feature or they had a bug that they wanted to fix, they'd have to wait months to see anything happening. And so that's where Agile was born. Basically, the idea here was we take this whole waterfall kind of timeline and squish it down into 2 weeks, and where you spend a couple of hours planning, and then you spend the rest of the time iterating and deploying features to users. So this means instead of releasing a version of a product once per year, you're actually releasing multiple times per day. And so naturally, when you shift your release cycle, this significantly different tools and methodologies start to arise. And so some of these technologies have been around for a while, but you're starting to see them become more popular because of this shift to this DevSecOps type of work. All right, so where does this leave security? The shift to Agile and DevOps, definitely a good change. Means businesses can adapt faster to user needs, and it's what enables startups to move so quickly, and kind of why you're seeing so many pop up all over the place. However, this faster pace of development leaves traditional security in the dust. And so, as I mentioned previously, in a waterfall style of development, you'd write all your code at once, and then right at the end, you'd basically do all your security testing and make sure that the code you're releasing was secure. Now, this model doesn't fit if you're changing your code base daily and you need to wait a couple of weeks to get a security audit done. And so you start to see a need for more security automation. And so that's exactly what DevSecOps is. It's the intersection of security and DevOps, and it's the automation of security testing that allows security to actually keep up with the pace of today's development. And so at its core, this requires an engineering culture shift to where engineers are developing and writing code with security in mind first. It means introducing tools and processes into the developer workflow that will allow you to write more secure code by default. And it means only making security everyone's responsibility rather than just a small team's, right? And this is the only way to ensure that you're staying secure in today's world. Now, I'm a developer at a startup, and I'd be thinking, like, why would I introduce extra friction into my workflow? After all, the startup mantra is move fast and break things. So I actually want to make the argument that if you don't introduce secure development processes into your workflows early on, then you're actually going to pay for it, like, kind of long term, right? You're going to reduce your velocity long term. If you don't worry about security at all and you just start pushing code, you will move faster. There's no doubt, right? However, you will get breached, and it's inevitable that you will. If you aren't thinking of security, then the costs will actually be far greater than if you had paid attention to security in the first place. So average data breach in the US costs about $8 million. And it may not cost you $8 million directly, but consider at a stage where users are already taking a risk by using your product over a more established one, you definitely don't want to be adding more reasons for a user to not check out your product. And in that same vein, once a breach does happen, you'll then need to do a postmortem, go back and evaluate your systems to see the extent of the data breach, and then frantically start implementing all of these security processes that should have been there from the start anyways, because you don't want to go to your customers and say, this breach happened, but we've changed nothing. And so overall, it's a safer bet to be proactive and rather than reactive. And this will allow you to actually move faster and break less things. Okay, so what does DevSecOps look like in practice? The thing to remember is that the earlier in the process you can get feedback back to the developer, the faster things go. So developers write so much code that it's difficult for us to remember how to debug some of the code that we wrote weeks or even months ago. And so if you get feedback on your code a few minutes or hours after you've written it, it's still fresh in your mind, and the fixes are fairly trivial most of the time. So most DevSecOps tools should be deployed in your CI/CD pipeline, and this is where your code gets built and deployed. And this is the best place to put your security checks for sure. So again, the thing to remember here is that you want to integrate security completely automated into the developer workflow, and you don't want to have it run manually by a one-off developer, because then it'll never get run. Okay, so if we take the example of a typical developer workflow where you write your code, you push it up to GitHub, this will kick off the CI/CD build. Then it'll, once that successfully passes, it goes to staging and then production. And then maybe you have some monitoring tools to detect anomalies or bugs in production. And so in this example, there's no security built in pipeline. And when the security team, goes in and looks at production and detects a bug, they'll have to spend time reproducing it, finding out who the code owner is, working out what parts of the code base was involved so that they can actually go and talk to the person and work with them to fix the bug. And in many cases, these bugs get caught months after they've been deployed. So the developer likely lost all the context that they had when they wrote this bug, and it increases the time that it takes them to fix it. And remember, all of this is being done under this time pressure because this bug exists in production, which means user data is at risk. So let's take an example where security is ingrained into the process. In this example, there are automated checks being run as soon as the code hits the repository, right when it's being built. And so I'll touch on the types of checks in a second, but if we take a high-level example here, if a bug gets caught as soon as the code hits the repository, and the developer gets notified maybe on email or on Slack, they're quickly able to go in and fix it because they just wrote this code. And so the idea is to find as many bugs as possible before a developer moves on to the next task and before it has a chance to actually impact users. And this is by far the biggest benefit of DevSecOps. All right, so what does this look like, in practice? And so this is not a definitive list, but a good starting point is to have one of each of the following of the three tools. And so on a high level, you want a software composition analysis tool. So this looks at what your software is composed of. The static analysis tool, which will scan your code statically, and then a dynamic testing tool, which will look at it dynamically. And so there are other types of tools in place that you can put, but I think these are kind of the best bang for your buck kind of baseline to establish a baseline level of security before you go into more advanced types of tools. So if we take software composition analysis, all it is just a 3D scanner, a third-party library scanner. So it just looks at all of your dependencies and sees if any of them have a known vulnerability within them. So as I mentioned previously, 80% of the average code base is up of 30 third-party libraries. So given with the rise of open source, this is pretty common for most code bases to have a lot of vulnerabilities kind of hidden inside of them. And so basically, SCA tools will just scan your code to find all the open source libraries that are being included, and then they'll compare them to a list of publicly known vulnerabilities called CVEs. So CVEs are common vulnerability and exposures. It's just a list of all vulnerabilities that existed kind of since 1999. And so if you were to manually go through and compare this, it would take forever. But as the tool completely automate this process so that make sure that you don't have any known vulnerabilities existing in your code base. And the best example I can give here, of course, is the Equifax breach. And so this breach was actually just a result of Equifax using an old version of Apache Struts, which is just a web application framework. So in production, they had used this version of Struts, and it had a known vulnerability that was published as a CVE. So when hacker realized that they were still using this version, they basically just went in and were able to use a very trivial exploit that was basically public to kind of get 148 million people's data. All right, so when it comes to SCA tools, especially as a startup, Dependabot is a really good one if you're on GitHub. It's basically just integrates directly into the workflow. It'll scan your code, and what it'll do is not just find vulnerabilities, but it'll automatically patch them as well. So as a developer, you can just set it and forget it, and you basically just ensure that you don't have any vulnerable code imports in your application. Sneak is another great one if you're not on GitHub, so it works on GitLab and Bitbucket, and it also goes a bit further beyond code, kind of scanning your code, and looks at containers and infrastructure code as well. So next we've got the static testing tools, or SAS, static application security testing tools. These sit a little bit further in the pipeline, usually in your CI/CD. And basically what these do is they scan your code and look for vulnerable code patterns that you're using. So they're looking for things that have caused bugs in the past and are usually searching for OWASP top 10 things. So SQL injection, cross-site scripting, bad access control, authorization problems, stuff like that. I don't want to go into kind of what these vulnerabilities are, but if you search OWASP top 10, it's a list of the most top 10 most likely kind of vulnerabilities to encounter in your application. So strongly recommend you check that out. And so, yeah, once you set up a SAS scanner, it'll basically just start looking for bugs. And so LGTM is a great one here. Integrates into GitHub natively. Like I said, it'll just basically highlight the exact line where it detected the vulnerability. It'll tell the developer how to fix it and how it could be exploited if they were to actually send this into production. If you're not on GitHub, this is another great one. GitHub, GitLab, and Bitbucket kind of support for all three of those. And the other cool thing with Codacy is it does provide you a dashboard that'll allow you to kind of monitor your code quality over time and make sure you're not increasing the vulnerabilities in your code and getting more secure over time. Actually, dynamic testing is probably the most advanced of these tools, but the idea here is instead of just scanning your code, it's actually running a real version of your application, similar to how it would run in production, and running real inputs and payloads against this. And the idea is that it would try to kind of mimic how a hacker would attack your application. So this will allow, kind of less false positives because it's not just scanning. And so it'll look for the same types of bugs that static analysis tools look for. So like I said, SQL injection, XSS, bad auth, server crashes and timeouts. And so basically, it'll kind of ensure that this is like the final step that you'd want to have running after SaaS tools. This usually sits in CI/CD or sometimes in staging, just given the fact that it needs to actually be run against a live running version of your code. When it comes to DaaS tools, most tend to be aimed at larger enterprises. And so they come with enterprise price tags. So when it comes for a startup, the best suggestion I'd have is OWASP's ZA proxy. It's a really good starting tool. It's completely free. It's open source, and it's maintained by the team at OWASP. So it's specifically made to be really good at finding those OWASP top 10 bugs. And so once you set this up, it's fairly straightforward. It's really stable. It's really developer friendly, and it's very customizable to kind of make it work to your application. And I strongly recommend checking ZA proxy out before you kind of go to look and spend more money on a kind of more advanced DaaS tool. All right, so as a quick TLDR, SCA tools, software composition analysis tools, these just find bugs in your dependencies. Largely, you can just set them and forget them, as they'll automatically just make sure you're not introducing any vulnerabilities through your libraries. SAST tools or static testing tools just find bad code patterns. They provide a lot of good insights to developers and are usually fairly easy kind of fixes that you can kind of get some good wins there. And then dynamic testing tools or DaaS tools, they find real exploitable bugs against a real live version of your code base, but it is a little bit trickier to set up just given the fact that it has to run. All right, so once you've got this baseline level of security, you may want to have more advanced testing in place as you kind of look to increase your security posture further. I'm biased, of course, but this is where I'd recommend fuzzing. It's one of the most critical components in Microsoft's SDLC, and a lot of the large tech companies are actually doing it at scale. However, fuzzing is really annoying and difficult to set up, and that's exactly what we're working on at Fuzzbuzz. So I strongly suggest you check out the workshop we're doing after this talk on fuzzing. My co-founder Everest is running it. He worked on the Google Chrome fuzzing team, so he knows what he's talking about a lot more than I do. And so even if you only stay for the first 5 to 10 minutes, it's a great idea to just kind of get familiar with what fuzzing is on a high level. Beyond fuzzing, you'll also want to look at adding tools on the development cycle. So looking at firewall monitoring tools to make sure none of the bugs that have snuck past your kind of great automated testing pipeline that you've just set up. And of course, the last thing and the most important thing of DevSecOps is to continue to push for a security first culture within your organization. So having all of these tools in place is a great start. But if developers are ignoring the bug reports and view these tools as a nuisance, then you've done nothing but introduce more friction into their workflow. So ensuring that everyone understands the value of these tools and ways that they can keep your code secure is pretty key to making sure that you stay continuously secure with DevSecOps. And so if you got any other questions, my email's up there. Feel free to ping me about anything, as I mentioned. I'll also be sticking around for the remainder of the conference, so feel free to hit me up later as well. Other than that, see you at the fuzzing workshop, and enjoy the rest of your conference.
That was fantastic, Andrei. Thanks a lot for sharing your insights. I had some personal painful experiences with security incidents in the past, so I can vouch for how important this is to take care of that. So very much appreciated. Thank you for being with us virtually today at Texavania.
Thank you, Philip.